After World War II, modern cryptography was born with the advent of digital computers. A classic algorithm from 1975 was the data encryption standard, DES. DES worked by breaking data to be encrypted into 64-bit blocks, so encrypted messages 64 bits at a time, which allowed the confusion and diffusion of the algorithm to affect blocks of 64 bits instead of just blocks of 6 or 7 or 8-bit characters. DES used a 56-bit secret key to control the encryption and decryption by selecting different scrambling functions. The picture on the right of the slide shows how DES works. The inputs came down from the top, and then the input would go through a scrambling function F and be XORed into the message, and the results would then go down to the next scrambling function and so on. There would be 16 rounds of scrambling, and you get the ciphertext at the end. 56 bits might seem a little odd. You ask, why isn't it 64? Well, presumably the key size was chosen so that only the National Security Agency could brute force or otherwise break 56-bit keys. That's a philosophy known as Nobust, nobody but us. And historically, the United States has encouraged the adoption of cryptography, which the US thinks that it can break, but it thinks that no one else has the resources or money or knowledge to be able to break. DES, as far as we know, was unbroken by anyone but the NSA until 1998. In 1998, some researchers took about $250,000 of field programmable gate arrays and were able to brute force all 2 to the 56 DES keys in a few days, and at that point, the algorithm had been publicly broken. Whether or not some other intelligence agency of some other country had broken it before then remains an open question. An important lesson to take away from all this is that all these algorithms we've seen were created, and at the time they were effective, or people thought they were effective, and then they were broken. It gets more complicated and more expensive to break them, but eventually every cryptographic algorithm designed has been broken by suitable application of being clever and a lot of computational resources. That means when you use another cryptographic algorithm, the question is not whether it will be broken, but rather when.